Um, okay, so it says figure. Let's draw out the figure. So we want 40. All right, so figure for 4.7, two blocks are connected by a string, and the upper block is pulled up by a different string. The masses of the upper and lower block are 300 and 240 grams. The string between the blocks will break if its tension exceeds 3.6 newtons, and the string which pulls the combination upward will break if its tension exceeds 7.8. What is the largest upward acceleration that the block can be given without either string breaking? All right, so to do this, we're gonna have, well, since this is our figure, we're gonna have, see, tension 1, tension 1, mass 1. We're gonna have weight being pulled down. We're gonna have tension 2, mass 2, and we're gonna have the weight 2. But weight 2 is gonna consist of mass 1 plus mass 2 times gravity. So let's write out the equation. Tension 1 minus M1 plus, well, it's not an equation, it's just how the tension of the summation of tension forces, or the summation of forces looks. So M2 G equals M1 plus M2 of A, and we have 7.8, which is the tension, minus 300 grams plus 240 grams. 9.8 equals 300 plus 240 grams. So acceleration. Okay, so we have 7.8 minus 0.540 kilograms, because we have to convert our grams to kilograms, right? So let me write this up here real quick. So if we have 540 grams, all we need to do is just, so we have 1,000 grams by 1 kilogram, which consists of 0.540 kilograms. Um, Times 9.8 equals the same thing, 0.40 kilograms times 8. So we have 7.8. Let me, what is 5.4.540 times 9.8.540 times 9.8. That's gonna give us negative 5.292 equals 0.540 acceleration. So when you subtract these two values, 7.8 minus 5.292, you get 2.508 equals 0.2540. So divide that value, cancels out, so you're left with acceleration. So when you divide the 2.508 by 0.540, you get 4.64 meters per second. So that will be our acceleration. Okay, so we're done with part A. So now we're gonna move to part B. Part B says if the upward acceleration is slightly higher than this, which string breaks? So let's just write out our tension, our summation of tensions, and mass of tension 2. It's mass of 2 gravity equals mass 2 acceleration. So we have our 3.6 minus our 240 times 9.8 equals our 240. It's in grams, so we have to convert that again. Times acceleration. This is also in grams, so when we do this conversion, we end up with 0.240 kilograms, which is this one over here to our right, equals 1.2 1.2. Wait, I forgot the acceleration. No. Acceleration. Let me just also equals 1.248 newtons, which is this value here. Oh, no. Which is this. And this is this. Okay. So when you figure out the acceleration, let me just divide 0.240 by 0.240, and your acceleration is 5.2 meters second square. Oh, I forgot the square. Okay, so that is for tension 2. So let's find out now also for tension 1. Let's figure out since that's a tension, let's find out the tension for 1. So for that is tension 1 minus m1 plus m2, mass of 1 plus mass of 2, times gravity equals mass 1 plus mass 2, acceleration. So let me see, this becomes tension 1 equals mass 1 plus mass 2, A plus G. Because all we did was just move all we did was move this value here towards the right to isolate T, because that's what we're looking for, tension 1. So we have 300 plus 240. Remember, this is in grams. So at the end, you're going to have to convert, times 9.8 plus 5.2 meters second square. This comes out to be 0.54 kilograms times, let me get the value of that real quick. Okay, so when you add 9.8 plus 5.2, you get 15. Don't worry about the variables, just get the answer at the end. So when you multiply 15 times 5.4, 0.541, you get 8.1 newtons. So what was our initial? Our initial was the conventional upper will break if its tension exceeds 7.8. So it cannot go past 7.6. So our races. So our 8.1 newtons does exceed, is greater than 7.6 newtons, which exceeds. So which that cannot be possible, because then the strings will break. So if the acceleration is greater than what we originally got in letter A, 4.64, if the acceleration is much more higher than that, which we did get for B, which is 5.2, then the upper string will break. Does that make sense? Okay, so let me say that again. So since our acceleration for A was 4.64, anything higher than that, then the string will break. Our string for the first string will break if the acceleration is higher than 4.64. Like for example, in B, our acceleration is 5.2, thus it gave us a total force of 8.1, the exceeding the 7.6. Thus, it string A will break. String A will be considered this one.